Welcome to my channel Chemica Chemistry Classes. Today we are going to discuss another topic of organic chemistry, that is inductive effect, resonance and many more. So we will start with inductive effect. Inductive effect. I will take one example like this. In a CH bond, the two atoms have almost the same electronegativity values, right? So as a result, the shared electron pair will be nearly equidistant to the two atoms, right? So in case the hydrogen atom is replaced, this hydrogen atom is replaced by another heteroatom or a group of atoms which is more electronegative than carbon atom, the shared electron pair will be permanently displaced towards the more electronegative atom or group. This electron displacement is generally represented by an arrow in the center of. When this hydrogen is replaced by some more electronegative atom like X, then this is shown by this arrow X. So this is displacement of electrons towards X. Result of the displacement, the covalent bond acquires some polar character. We will discuss what is the effect to a long chain of carbon atom with more electronegative atom or a group, and we will say like chlorine. Like this, when there is a long chain carbon and there is attachment of chlorine atom, then what happen? Like this is in delta negative, this is delta positive. Then first see, this is carbon 1. This carbon 1 and Cl bond, the shared electron pair get displaced towards the chlorine atom, and as a result they develop a partial negative charge, while carbon atom acquires a partially positive charge. This displacement is further transmitted to another atom in the chain, like we will give them number 2, 3, 4, carbon 2, carbon 3, carbon 4. But the magnitude of the displacement goes on decreasing. Magnitude goes on decreasing as with increase in the distance, with increase in distance of carbon atoms from chlorine. In simple word, delta positive charge on carbon atom 2 will be less than carbon 1. This delta positive charge is greater in carbon 1 as compared to 2 and as compared to 3, 4. Like, so will be less on in carbon 1, right? So the polarities of the carbon atom in a chain have been included. Polarities like this. This carbon 1, this has a positive delta. They all have positive delta. Like in the more polar bond is attached to electronegative atom. So the polar bond in the chain induces polarity in the covalent bond. This type of electron displacement is referred to as a inductive effect. This is inductive effect. Inductive effect is the permanent displacement of electron along the chain of carbon atom due to the presence of polar bond at the end of the chain, and this is the inductive effect. Inductive effect is also sometimes called as a transmission effect. Inductive effect is most powerful only at the carbon atom to which heteroatom, like in this carbon atom is carbon 1, which is directly attached to the more electronegative atom, in which the heteroatom is connected and decrease sharply as you move away from heteroatom. Inductive effect dies off quickly beyond 2 carbon atoms from the heteroatom. Inductive effect is of two types: positive inductive effect or negative inductive effect. Negative inductive effect refers to electron withdrawing inductive effect, that is electron withdrawing inductive effect. and this positive one refers to as electron releasing inductive effect. What happened as inductive effect is of two types, positive and negative. Positive one is electron releasing and negative one is electron withdrawing, right? So the electron withdrawing, this one, inductive effect, the electron pulling heteroatom or groups which have electron attracting capacity greater than hydrogen atom are called electron attracting, electron pulling heteroatoms or electron withdrawing group. Such a group, if attached to a carbon chain, cause displacement towards itself, and this is called the minus effect, minus I effect. They are like this. When group is attached here, so they are this electron withdrawing heteroatom, displacement of the group towards the heteroatom or a group, like this. These are some of their examples. Etc. Electron releasing means the atoms or group which have electron attracting capacity lesser than the hydrogen atom. They are electron repelling or electron releasing group. Such a group is directly attached to carbon atom and like this, they are directly attached to carbon atom and cause a displacement of electron towards the carbon chain, and this is called the plus I effect. This is all about inductive effect. There is different type of application like stability of a reaction on intermediate. It explains the relative stabilities of reaction, polarity of covalent bond and dipole moment of organic chemistry. They tell us the electronegative difference, orientation of polar covalent bond. Different types of application are there for inductive effect. Next is resonance. Resonance is something which is very different than others effect, right? So in resonance, what happened? Resonance has been observed that certain molecular structure can be represented more than one Lewis-Strauss formula, but none of the Lewis formula is able to explain all the known properties of the compound. For example, we can take example of carbon dioxide like this, and this is carbon dioxide. According to a formula, the carbon-oxygen bond length should be 122 picometer and the experimental values of carbon-oxygen bond length is 115 picometer. It means the structure fails to explain the known properties of carbon dioxide. Similarly, another properties of carbon dioxide. So what happened? This is a one structure of like this, and I will explain you the other structure of carbon dioxide and then other one. Negative here. Right, same as in resonance structure. So resonance hybrid, the term resonance hybrid, according to that, the actual structure of carbon dioxide is intermediate between 1, 2 and 3 structure. The exact resonance structure is intermediate between these 3 structure, and this is called the resonance hybrid. Resonance hybrid although represents the actual structure of the molecule but cannot be represented on the paper. So these structure 1, 2 and 3 are the resonating structure, or we get conical structure or contributing structure, and the resonance is represented by putting double headed arrow between them. Double headed arrow like this, right? So when a compound can be represented by more than one structural formula which differ only in the arrangements of electron pair and not the atom, each of this electronic structure can explain most but not all the observed properties of the compound. Then the actual structure is intermediate between the various electronic structure, and this is called the resonance hybrid, and the phenomena is called the resonance, and the various electronic structures are called the resonating or contributing structures. We can take example of benzene also. This is mentioned in NCERT, example of benzene. Right. So the hybrid is like this. This is a resonance hybrid. Properties of resonance hybrid is stability, the resonance energy, more the resonance energy of the molecule, greater is the stabilization of the compound, bond length. Next is resonance effect. We discussed what is resonance structure, what is resonance hybrid. Now term is resonance effect. When an atom or a group is directly linked to one of the atoms of the multiple bond by a single bond, it is said to be in conjugation with an unsaturated or pi atom. Right. So the flow of pi electrons from one atom of the conjugated system to the other due to the phenomena of resonance in this conjugation is called the resonance effect, or we call as mesomeric effect. We can write here as R effect or M effect. Resonance effect or mesomeric effect or conjugative effect. In case the compound in question is having a conjugated system or a double bond, the mesomeric effect is transmitted through the whole of the conjugated system, and thus the effect is called the conjugated effect. Types of resonance effect. Resonance effect is of two types, minus R or positive R. When the electron displacement occur away from the chain or a ring of the molecule, it is called the away minus I effect. Right. So examples, such an effect is caused by electron withdrawing group like carbon dioxide, cyanide, nitro. They are the adjacent to carbon-carbon multiple bond. So in minus I effect, what happen? This is minus R effect. Sorry, in positive R effect, what happen? When an electron displacement occurs away from the atom or group, it is called the plus R effect. Like this, I will give you one example. This is shifted here, and there is lone pair that is shifted here. So there Cl, sorry, this is positive comes here and negative comes here. So the inductive and mesomeric or resonance effect when played together, when present together, may act in the same direction or oppose each other. So resonance effect and mesomeric effect are the one and the same thing. Right. So we will discuss resonance effect. Resonance effect is of two types, minus R and plus R. Minus R is what? Minus R is when the electron displacement occur away from the chain or a ring of the molecule. So their example is in positive R effect, what happen? When the electron displacement occur away from the atom or group, it is called plus R effect. Their example is hydroxide and H2. Right. So next is the electromeric effect. What is electromeric effect? As from the name, it is going to be clear. This is very easy, and this is same like other effects. While, as you understand, inductive effect, electromeric effect is a temporary effect. As I told you in my previous video, like this inductive and electromeric effect is a temporary effect operating in unsaturated compounds only at the demand of a nearby attacking region. It involves complete transfer of shared pair of pi electrons of a multiple bond to one of the bonded atom. Like this. So, during the attack of a nucleophile at the carbonyl group, when nucleophile is added or is attacked or removed, then what happen? The pi electron pair bonding the carbon and oxygen is transferred completely to the oxygen, thereby polarizing the carbonyl group. The displacement of the electron pair to oxygen rather than to the carbon is due to the greater electronegativity of oxygen as compared to carbon atom. So the complete transfer of the shared pair of pi electron of methane bond to more electronegative electropositive atom of the bonded atom due to the requirement of alternating reagent is called the electromeric effect, or we simply call E effect. Hyperconjugation. We have already discussed inductive effect, that the alkyl group are electron releasing in nature and cause plus I effect. The electron releasing nature increases as methyl, ethyl, isopropyl, tertiary butyl. So it has been observed that in many organic molecules, this order of electron releasing nature of alkyl group gets reversed, particularly when they are linked to the unsaturated carbon atom. In order to explain this anomalous electron releasing pattern of alkyl group, the Baker and Nathan developed the concept of hyperconjugation. According to this concept, if an alkyl group carrying at least one hydrogen is attached to the unsaturated carbon, it releases electrons of CH sigma bond towards the multiple bonds with polarization of multiple bond. And its structure, let's understand this structure. This is first structure, and this is second one, right? So this is a canonical structure, second one, and there is no bond at all between the carbon and oxygen atom, right? Carbon and hydrogen atom, sorry, there is no bond between carbon and hydrogen atom. Hydrogen is here. So this type of displacement of sigma electron towards a pi bond, this is known as a hyperconjugation, right? So this is all about hyperconjugation, resonance effect, inductive effect, electromeric effect. Thank you.